Hello everyone, welcome to Rashmi YouTube channel. In this session, I am going to continue with the second PUC Maths chapter 1, that is relations and functions. So now I will continue with exercise 1.1, that is sixth question. Okay, so you can see from your textbook, the sixth question is show that the relation R in the set 1, 2, 3 given by R is equal to 1, 2 and 2, 1. It is symmetric but neither reflexive nor transitive. So here they have given, let's take set A is 1, 2, 3. This is the set which they have given. Now the relation they have already defined, that is R is equal to 1, 2 and 2, 1. I have to check whether this is reflexive, symmetric or transitive. Let me start with first, that is reflexive. Check whether it is reflexive. Reflexive means I have to get 1, 1, 2, 2 and 3, 3. So all these three elements are not there in this relation. So if all these three are not there, then we can call this relation as not reflexive. Now the next is I have to check for the symmetric. See, in this 1, 2 is there and 2, 1 is there. So this relation is symmetric. Why? Because if A, B is present in the relation, then B, A is also present in the relation. So this relation is symmetric. Next, transitive. So to check for the transitive, what should I have in the relation? If 1, 2 is there in the relation and 2, 3 should be there, and again 1, 3 should be there. So these three are the elements for the transitive relation, but all this 1, 2 exists, but 2, 3 and 1, 3 does not exist in the relation. So we can call this as nor transitive. Okay, so as per this question, we have already proved that the relation is symmetric, but it is neither reflexive and nor transitive. Next, we will go with the seventh question. Show that the relation R in the set A of all the books in the library of a college given by R is equal to x, y and x and y have a same number of pages is an equivalence relation. So how should we show this? So here they have given a set A as books in the library. Now, and they have given relation as x, y and x and y have same number of pages. So as per this relation, we have to define the relations. Let me start with the reflexive. So how the relation is defined? I have to define the relation as x, y and x and y have same number of pages. So as per these conditions, I can write x, x and also I can write x, y. I can write y, y. Why? Because x is having same number of pages and x itself is having same number of pages. Y is having same number of pages and y itself will be having same number of pages. So I can define this relation as reflexive relation. Now the next relation, I can define x, y and y, x. Why? Because all the books are having same number of pages. So So if in case if x has 100 number of pages, then y will also having 100 number of pages. So if y is having 100, then x will be having 100. So all are having same number of pages. So I can define the relation x comma y belongs to r means y comma x also belongs to r. So I can define this relation as symmetric. Next, I have to check for the transitive. See, if x comma y belongs to r and y comma z belongs to r, for the transitive I should take these two. So that is x comma z belongs to r. So let me check this condition. X is having same number of pages and y is having same number of pages. So I can define x comma y. If y is having same number of pages and z will be having same number of pages. So if I take x, y, z are the three books in the library, and x, y, z all three books is having equal number of pages. So I can definitely define this relation. X and y will be having same number of pages and y and z will be having same number of pages and x and z will be having same number of pages. So I can define this relation as transitive relation. So now the 8th question. Show that the relation R in the set A is equal to 1, 2, 3, 4, 5. It is given by R is equal to A, B and A minus B is even. It is an equivalence relation and show that all the elements of 1, 3, 5 are related to each other and all the elements of 2, 5 are related to each other. But no element of 1, 3, 5 is related to any element of 2, 4. So I have to let me take, they have already given set A is equal to 1, 2, 3, 4, 5, and they have given the relation as R is equal to A, B and mod of A minus B is even. So I have to show this is a equivalence relation. Equivalence means I have to show it is reflexive, it is transitive, it is symmetric, and also it is transitive. So as per reflexive condition, I have to define the relation as R is equal to 1, 1, R is equal to 2, 2, R is equal to 3, 3, 4, 4 and 5, 5. This is the reflexive relation. So can I write this relation as per this condition? Just check it. A, B, A minus B is even. So as per this condition, when I take 1 minus 1 or 2 minus 2, 3 minus 3, 4 minus 4 or 5 minus 5, this will be equal to 0. And 0 it is an even number. So I can define this relation as reflexive. Next, I'll check for the symmetric. So for the symmetric, what should I write? I can take 1, 3. So I have to define the relation as per this condition. So when I do 3 minus 1 or 1 minus 2, so 1 minus 2 will be minus 2 and mod of minus 2 will be plus 2. So if I write 1, 3, I can write 3, 1 also. If I write 1, 5, I can write 5, 1 also. And even here 1 minus 5 will be minus 4, mod of minus 4 will be plus 4 and it is even. So 5 minus 1 will be 4, that is even. So like this I can define relations for the symmetric. So even I can also define relation as 2, 4 and 4, 2. And here 2 minus 4 will be 2 and that is even. 4 minus 2 will be 2, that is even. I can define the relation as, okay. So when I define 1, 3 exists and also 3, 1 exists, 1, 5 exists and 5, 1 exists, 2, 4 is there and 4, 2 is there. So from this I can define the relation as symmetric. Let's check with the transitive. So if I write 1 comma 3 and 3 comma 5, I have to check for 1 comma 5 for the transitive relation. 1 minus 3 is minus 2. Mod of minus 2 will be plus 2, that is even. 3 minus 5 will be 2. 2 is even. 1 minus 5 will be minus 4 and mod of minus 4 will be plus 4, that is even. So as per this condition, I can define this relation. So I can write this relation as transitive. So from this relation, you can also see that when I take two odd numbers or two even numbers, and when I take subtractive of two odd numbers or even numbers, it will result in a even number. So 1 comma 3, 1 and 3 are odd numbers. 3 comma 1, 3 and 1 are odd numbers. 1 comma 5. So here 2 are odd numbers. So when I minus two odd numbers, that will be a even number. And even when I take two even numbers, and difference between two even numbers will be again a even number. But if I take 1 comma 4, that is one odd number and one even number, the difference between one odd number and one even number will be a odd number. See, 1 minus 4 will be minus 3. This is a odd number. So the condition is, when I take the difference of two numbers, that result should be an even number. So you cannot take one odd number and one even number. For this condition, you have to take two odd numbers or two even numbers. So from this, you can tell that here the set 2 comma 4 are two even numbers and 1 comma 3 comma 5 are the odd numbers. So here 2 comma 1 are related to each other and 1 comma 3 comma 5 are related to each other. But 1 comma 3 comma 5 are not related to 2 comma 4. Why? Because this is the set of odd numbers and this is the set of even numbers. So there will be two sets. One is 1 comma 3 comma 5 and one more will be 2 comma 4. So here none of the elements of this set belongs to none of the elements of this set. Let me take this as A dash. So from this relation I can define this relation. So elements of 1 comma 3 comma 5 are related to each other and elements of 2 comma 4 are related to each other, but no element of 1 comma 3 comma 5 is related to any element of 2 comma 4. Why? Because this is the odd set and this is the even set. And also the relation is reflexive, symmetric and transitive. If all three conditions exist, then we can call this as a equivalence relation. Okay. Then we will continue with the 9th question in the next session. And please let me know in case if you have any queries. I will try to solve the queries as soon as possible. And thank you for watching my video, and please don't forget to like, share and subscribe to my channel.